Hi there, I'm Rick McGeer. I'm just going to spend 5 minutes introducing Rob. Just some quick basics on the InstaGENI rack. We designed it for the mesoscale. The native aggregate managers are ProtoGENI and foam. When you boot the thing up, it'll be running ProtoGENI. It runs foam to hook up the OpenFlow switch on it. The idea is that you can also federate it to Planet Lab and GENI Cloud immediately and out of the box, and Rob will show some demonstration of that. And also, we left lots and lots and lots of space in the rack for you to put your own stuff that you buy yourself and donate to the GENI community. Hint. The idea is that we wanted to make this really easily deployable. We have two options. We have 220 volt power and 110. The network connection that you need is just 10, 100, 1,000 base T, nothing exotic. One of the things, everything I needed to know about distributed infrastructures I learned from Planet Lab, and the key thing was make sure that you can boot the thing remotely easily. If I never spend another day rebooting nodes in Moscow, I will not die unfulfilled. And it's designed to let you program the networking all the way down to layer 2. The hardware is basically a rack of ProLiant 360 G7s. For next year, we're working on a G8 series, 6-core dual socket quad NIC, which gives you 4 NICs and 12 cores per machine, 5 experiment nodes. That means 60 nodes to play with. Rob can tell you a little bit about how much we've been able to bring up. The control node simply looks like another Emulab boss node, and we have our most advanced OpenFlow switch. Nick Baston from Big Switch told us which one to buy, the 5406 with the V2 line cards, which gives us our, at least HP's, most advanced matching capability. We're going to have 8 going out in year 1. 21 of them's already been delivered. We've got another one on order, and I'm ordering a bunch more this week. 24 will go out in year 2, all in USA. For those of you who want to buy your own racks, for not a lot more than our internal cost, and I know because I know the internal cost, your HP SLED, that's our State, Local, and Education Division, has put together an attractive program if you want to buy some. If you're abroad, come and see me, and I will hook you up with the right people from HP in your country. But the important thing, the only important slide in this presentation is this one. This is just ProtoGENI, all right? The idea about this rack was it was going to be the most vanilla, easy to use, most familiar thing that you could ever see. You can instantiate, it's just a ProtoGENI rack with the ability to instantiate Planet Lab nodes. Of course, you could do that on Emulab. It's got a built-in OpenFlow controller. It's got the ability to get rid of it, to allocate external resources using FLAC. Rob will show you some of that. It's got the ability to network other ProtoGENI resources, and it's got the ability to connect to campus resources. But you can do it all using exactly what you've been doing before, and Rob will show you that. And with that, I'll shut up and turn it over to the guy who does the work.
Okay, so so as Rick said, one of the virtues of this rack is that it's just based on stuff that we've already built. So I'm going to, over the next 14 minutes and 53 seconds, go ahead and create a slice on this rack and on some other resources. So I'm going to go ahead and start it creating and then kind of talk through what the slice actually is. And what I'm mostly going to show you is just the infrastructure. Some of the, I'm not really going to run an application on it. You're going to see some of that in the next session in the Slice Around the World demo. So I'm going to leave that. I'm going to leave an actual application to them. So you'll notice that this is a standard FLAC interface that you guys have probably seen me demo before, or have probably seen in a tutorial or in the evening demo session. It's got the Utah GENI rack on it now, which is currently the only one that is up, but I believe the next few have been ordered. And we've also got, I'm also going to use some resources from the Utah Emulab cluster and from GENI Cloud today. So the first rack is up, and it's solid enough that we're going to use it we're going to run a tutorial entirely on it this afternoon. As Rick said, it's the InstaGENI racks are kind of designed to be relatively light in terms of what they ship with, so that people can, first of all, so we can ship a lot of them, but also so we can get, so people can add their own equipment to it later. So this rack is currently advertising. It's got 5 PCs in it. A couple are in shared mode. So one of the things that we've done is substantially beefed up our support for supporting virtual machines. We're hoping to create something like 40 virtual machines on each one of these physical machines in the tutorial today. We'll see if that works. As Rick said, it's got this OpenFlow capable ProCurve switch on it. And so let's see if it's done parsing my RSpec, and I'm going to go ahead. So this is an RSpec that I created a couple of days ago that I'm going to go ahead and start. Let's see, and start going with. So I want to show you. So I'm going to use this experiment, which unfortunately the font size on this projector doesn't show up that great. So I'll have to talk through stuff to show some of the interesting features of this of the InstaGENI rack. So these bluish rectangular nodes at the top are the ones that I'm creating on the Utah InstaGENI rack. These are all VMs because we only have five physical machines in there. And then I've got a bunch of physical machines in the Utah Emulab cluster, and I'm able to make a VLAN that goes between them. So any place that we have nice enough connectivity that we can actually create VLANs across backbones or whatever, we can just go ahead and create those VLANs across different aggregates in the same way we create them inside an aggregate. Another important feature that we've got of the InstaGENI rack is that these are going to different campuses, and some campuses are rich enough in IP addresses that they can just assign a pretty large subnet to the rack, and some aren't. And some experiments need that external connectivity, and some don't. So the virtual machines that I've asked for here actually mostly are not going to get public IP addresses. However, I've got this one here that is going to be kind of my gateway to the outside. And you'll notice I've got this little routable IP address checked, so the routable IP addresses are treated as an allocatable resource, so that only the local rack administrator can assign some range of those, and we can get and they get only given out to the specific nodes in experiments that ask for them. So you'll also notice that on the left-hand side, I've got a bunch of existing VLANs that I'm connecting to. So, we would like as much as possible to be able to just dynamically create VLANs or circuits or whatever to other resources, but in some campuses we're going to, have a limited number of those, or there's going to be things that are hand stitched to other sites, and so we've got the feature now that you can ask to join those existing VLANs. So one of the so actually I have one here that is joining the mesoscale OpenFlow VLAN. So when this slice is done getting created, I'm going to have connectivity to the OpenFlow VLAN that runs around the country, and I've actually asked for that both from the rack and from Emulab here. Another one that we've got set up is we've worked with some folks in Japan, coordinating with Aki, and so these VLANs here actually run all the way to Tokyo. So let's go through a little bit more about what we actually have in the rack. So the let's see. So the machines in the rack can be, at this point, in one of two modes. They can be allocatable as bare metal machines, and for example, the Slice Around the World demo later today is using a bare metal machine where people have the ability to go down all the way to, and work on the kernel or anything on top of it, and interact directly with the hardware. With the The nodes can also be dynamically added or removed to a shared pool where we're using the Linux OpenVZ containers, and you get a shared kernel, so it scales pretty well, and we can run a lot of them, but you don't get the ability to muck around with the kernel. This PC4 here that's got a red X next to it, that means it's currently allocated. I think it's to the Slice Around the World demo. Another thing that is new is that Rick mentioned federation with GENI Cloud. So we've got that up and running. So you'll see here these purplish nodes are GENI Cloud nodes. They're in Palo Alto. They're managed by a software stack that uses, I believe it uses OpenStack, and it's got the Planet Lab SFA on top of it. And you can see there are several different instance types that I can ask for, small, medium, large, and they just get their external connectivity through commodity internet, which is why I've asked for this external gateway machine that has a public IP address on it. And actually, this is going quicker than I thought. So at that point, that's actually it for my demo. So I guess I'll turn it over to Ilya a little bit soon. Oh, or to Heidi. Okay.